Welcome to the lesson, Earth's Days, Years, and Seasons. In this lesson, you will learn how Earth's changing position in space relates to hours of daylight and air temperatures in different locations on Earth. The vocabulary words for this lesson are rotation, day, revolution, year, season, equinox, and solstice. You can click each word to find out more about it. You probably feel like you are sitting still right now. So you might be surprised to learn that you are actually moving very, very fast. Earth is a sphere that constantly rotates or turns on its axis. You are always spinning around and around with Earth. The speed you are traveling depends on where you are on Earth, but you're probably going more than 1,000 kilometers per hour. Rotation is the circular motion of an object around a central axis. The spherical Earth rotates on its axis in a counterclockwise direction, completing a full rotation every day, or 24-hour period. As Earth turns, areas on Earth move in and out of sunlight. This causes each area to experience a period of daylight and a period of nighttime during every 24-hour period. This video shows how Earth's rotation affects daylight and nighttime on Earth. Click play to watch the animation again. On Earth, it appears that the sun is coming up at dawn and going down at sunset. But what is really happening? As Earth rotates, the area on Earth that is moving into sunlight experiences dawn. The area on Earth that is moving out of sunlight experiences sunset. Look at the pictures to see what dawn and sunset look like from space. At night, the stars seem to trace a big circle in the sky. But that's because you are viewing them from a rotating Earth. Did you know that there are 2 days during the year when every location on Earth gets 12 hours of sunlight and 12 hours of darkness? These days are called equinoxes, and they mark the beginning of spring and fall. Even though all locations receive the same number of hours of sunlight during an equinox, they do not all receive the same amount of solar energy. Earth's curvature causes the intensity of sunlight to be different at different locations. Click the pictures to learn more. Sunlight shines directly on the equator during an equinox. This direct light delivers a lot of solar energy. This is one reason why areas near the equator are usually so hot. Because of Earth's curvature, locations that are above or below the equator get indirect sunlight. This means that the energy from the light gets spread out over a wider area. Locations in the United States or Australia receive more indirect sunlight than locations in Colombia or Kenya. Because areas at higher latitudes receive less solar energy, they are often cooler than areas near the equator. Sunlight gets very spread out in the Arctic and Antarctic regions. Even though these areas are receiving 12 hours of light, the light is very indirect and delivers much less solar energy to each location. This is one reason why polar areas are so cold. When Earth rotates, how does it move? Click the correct answer. Right. The Earth rotates by spinning on its axis. At noon during the spring equinox, why does the sun feel hotter at the equator than it does in Alaska? Type your answer in the box. When you are happy with your answer, click OK. How much time does it take for Earth to make a complete rotation? Click the correct answer. Right! Earth makes a complete rotation in 1 day, or about 24 hours. Now that you've explored the science behind our planet's days, let's take a quick check to remember the main points. You learned that Earth rotates on its axis. You also learned that a full rotation occurs in a 24-hour period, or 1 full day. The curvature of Earth affects how much solar energy an area receives. The equator receives more direct sunlight than other parts of the globe. At higher latitudes, sunlight is less concentrated, so it is less intense. You have completed this part of the lesson. Please continue to learn about how seasons occur on Earth over the course of a year. You have just learned about how Earth's rotation on its axis causes periods of daylight and nighttime. Now we will look at what happens on Earth as it revolves around the sun while tilted on its axis. Did you know that when the sun goes down at the North Pole, it doesn't come up again for 6 months? And when the sun comes up, it doesn't set for 6 months. This happens at the South Pole too. Because Earth is tilted, one of the poles is always facing toward the sun, while the other pole is facing away. During the year, the position of Earth's tilt changes as Earth revolves around the sun. When the pole that was in the dark moves into sunlight, the other pole goes dark. As we go about our daily lives firmly anchored to the ground, our planet is actually traveling around the sun at great speed. Let's learn a little more about this. One trip around the sun, or one revolution, takes a full year to complete. Recall that a day is a rotation of Earth on its axis. Earth rotates 365 times as it travels around the sun. As Earth travels around the sun, its tilt causes the seasons. Summer in the northern hemisphere occurs during winter in the southern hemisphere. It takes 24 hours, or 1 day, for Earth to make one rotation on its axis. It takes approximately 365 days, or 1 year, for Earth to make one revolution around the sun. You might remember from math class that there are 360 degrees in a circle. If Earth moved in a perfect circle around the sun, it would move about 1 degree per day. Earth's axis isn't straight up and down, it's tilted at an angle of 23.5 degrees. Earth's axis always points toward Polaris, the North Star. This means that Earth's axis is always pointing in the same direction as it orbits the sun. This causes Earth's northern hemisphere to be tilted away from the sun during some months of the year, and to be tilted toward it during other months. This change in position causes seasons on Earth. Each season on Earth begins with an equinox or solstice. An equinox is a time when neither hemisphere tilts toward the sun. A solstice is a time when one hemisphere is tilted directly toward the sun and the other is tilted away. Click the pictures to learn about the equinoxes and solstices in the northern hemisphere. During an equinox, every location on Earth experiences 12 hours of sunlight and 12 hours of darkness. Earth's northern hemisphere is tilted away from the sun during the winter solstice and winter months. Short days and indirect sunlight in this hemisphere cause air temperatures to become very cold at high latitudes. The sun appears low in the sky because the northern hemisphere is tilted away from it. When the northern hemisphere is experiencing winter, the southern hemisphere is experiencing summer. As fall starts, air temperatures decrease as days grow shorter and sunlight becomes less direct. Earth's northern hemisphere is tilted toward the sun during the summer solstice and the months of summer. Days are longer during this time and sunlight is more direct. The sun also appears higher in the sky. The increase in solar energy during summer causes air temperatures to increase. When the northern hemisphere is experiencing summer, the southern hemisphere is experiencing winter. When do equinoxes occur? Click all of the answers that are correct, then click OK. Good job! 2 equinoxes occur each year when neither hemisphere tilts toward the sun. Why are summers often much warmer than winters? Click the 2 correct answers, then click OK. That's right! In summer, direct sunlight and longer days provide more solar energy to an area, so air temperatures increase. During which part of Earth's orbit is South America experiencing winter? Click your answer. That's not correct. Try again. That's it. South America experiences winter when the southern hemisphere is tilted away from the sun. That was a lot of information. Before we leave this lesson, let's take a quick look at what we've just learned. To begin with, we took a look at Earth and how it revolves around the sun. We noted that this journey takes a year, or approximately 365 days. We discovered that Earth is tilted on its axis. Finally, we learned that it is this tilt that causes the seasons. Congratulations on completing the lesson, Earth's days, years, and seasons. In this lesson, you learned that Earth rotates on its tilted axis and revolves around the sun. The tilt of Earth's axis causes seasons as Earth orbits the sun. Now that you've finished this lesson, if you wish, you can go back and review any part of the lesson again.